Okay, just give me a second. Right, so this is the week 4, and week 4 is going to be like the 2 parts. So week 4 we are going to talk about the stack and queue, and this is just a little variation of the linked list, and it's going to be pretty easy, right? So let's start. So our weekly objectives are this, and we are going to learn our second and third data structure called stack and queue. And objectives are, you have to understand the definition of the abstract data types and memorize the structures and the operation of stack and queue. So this is much more conceptual part, and this is more like actual data structure implementation issues, and here comes it, implement a stack and queue with a list, and understanding a symbol balancing example, which we are going to cover it more in the homework 2. Okay, homework 2, right? So let's start with the basics of this text, right? Before we really start, we are going to talk about little bit about the abstract data type. So abstract data type is an abstraction of a data structure. Write this bag. So in this bag supports operations like the putting in and getting out, right? And these are 2 operations. And there are data stored here, many. And it's actually the abstract data types specifies the data stored, like this, and operations on the data, like this, and then error conditions associated with operations. Yeah. So, for example, the abstract data type modeling of a simple stock trading system. So data stored of buy and sell orders, right? We put buy or sell orders, and these order informations are stored somehow, right? And the operations to support this system is that order buy, order sell, or cancel, or and so forth, right? And also there should be an error conditions, right? If we are going to put a buy or sell orders of a non-existing stock, then it should be an error, and we have to catch that. The abstract data type should catch these error types. And also canceling a non-existing order is a problem, so it's an error. So this abstract data type ADT should be able to capture it, right? So 3 things: data stored and operations. This actually corresponds to the properties, right? Yeah, properties, and this corresponds to what? Methods. And these are more like class point of view. This is more like software architecture point of view, or software design point of view. And this is more like data structure point of view, right? Or algorithmic point of view. But what we are talking about is are same, right? And we have these error condition issues, which we are not going to discuss throughout this course. But actually this is pretty important. But if you are going to do more advanced programming, error conditions and error handlings are most imperative ones, because that this is where this system like makes troubles. But what you're going to handle is that we are going to just assume that data are all right and operations are all making sense and so forth. So we are just focusing on the properties and methods parts of the classes, and also data structures, right? So basically this is the conceptual abstract data type definition. Okay. So we are going to continue this tag. So let's imagine this. So this is a little bit interesting idea, or the example. So this is what? So this is the backseat. So it's closed. The backseat of the taxi, and this is closed and it's open, right? And passengers come in and they take a seat, like the first seat and second seat, most uncomfortable seat, and third seat, right? And let's imagine that this is Professor probably, right? And this is prop Shin, and this is me, right? And actually I live here, around here, and prop Shin lives around here, and prop Lee lives around here. And let's imagine that we three of us together, we had a little drink at the Sinsong area, right here, and we took a cab. And then our route is this. Our route is that we are going to discharge. Discharge means Professor Lee is going to take off. Will get off the taxi firstly, and secondly, Prof. Shin arrives home, and finally, I'm the last one who is going to get off the taxi and pay the fare, right? So that's our scenario. And then who should sit and how and where, and that's the problem. So backseat of the taxi is just one way in, and one way out, and it's blocked here, closed. And we are traveling from the source to the destination. This is the source, and this destination 1, destination 2, and destination 3. And who should sit first and last? Of course, if you are smart, this is where I should sit, and this is Prof. Shin should sit, and this is Prof. Lee is going to sit, because that Prof. Lee is going to be the first one who take up the cab, and Prof. Shin is going to be the next one, and I'm going to be the last one, right? So to make this happen, I should be the one who go in, and the Prof. Shin should be the next one. Prof. Lee is going to be the first one. So Prof. Lee is going to be the first one who sits, and the first one who get off, right? Right. So we have this seat assignment. And actually, it's just a scenario of a taxi, but how about this? We have this big plane, and this is closed, and this is open. This is one way in and one way out, right? And we have a lot of cargo here. And cargo plane with one way in and one way out. How to organize the cargo loading in this case, right? So we can apply this idea to many different cases. So how it is structured, right? Now you see the familiar diagram. So how about linear linked list, right? Structures. So cargo object 1, cargo object 2, 3, 4, 5, 6 are stored like this. It's just a variation of a singly linked list. If we don't have the head or tail, this moment I just didn't draw it. We can always put the head and tail, like the head here and tail here. The difference is voluntarily giving up the access to the middle in the linked list. So we are just giving it up the access to the middle, right? Get eyes node. We are stopped doing that. In this case, what they are going to do is only accessing the first instance in the list. So only accessing this first instance of the list. We are going to call it top, right? So cargo object 1 is the top, right? So an item is inserted or removed from the stack from the one end called the top of the stack, right? So this is called what? Last in, first out, also called LIFO operation. So this cargo object 1, to make this cargo object 1 top, by inserting items only at the first index is only possible with this. So we insert cargo 6 here, right? It's the first index, right? And then we are going to insert cargo 5, and we set it up in the first index, and this would be second. And cargo 4, right? first index, second index, third index, right? They always insert the new items at the first index. First index, cargo 3, 2, 3, 4, right? So this cargo object 1 would be the first one, will be at the first node, and second node, third node, fourth node, fifth node, and sixth node. And insertion wise, this was the sixth inserted, and fifth inserted, and third inserted, and the fourth inserted, and third inserted, and second inserted, and first inserted, right? Like this. Okay, so these are the structure of this tag, and what we are going to do is to take things out from this tag, always access to the top, the first element and cargo object 1, and actually that's the element which got in the last time, right? It was the sixth insertion. So last in gets out first. So that's called the LIFO mechanism, right?